Hi there, this is John Bishop. I'm here with my very, very good friend, Dr. Nancy Flournoy, and we have a very exciting presentation prepared today that Nancy will be giving. So Nancy, just before we start, just introduce yourself a little bit there.
Okay, John, thank you very much. Thank you very much for having me. I'll share my screen and introduce myself.
And I'll unmute myself.
So, I'm Dr. Nancy Flournoy, and I am a distinguished professor emerita at the University of Missouri. My field is biostatistics, and I have a long career of research and practice in clinical trial design and analysis, and in particular, adaptive designs. So I'm not a biologist, but I have been very impressed with the LifeWave patches and have enjoyed working on this series where we discover the biology that the patches are being directed at and what the patches do. And so I'm happy to share with you what I've learned. So today we're talking about the glutathione patch, and the slide here tells you what in fact the company LifeWave claims about the patch. And so you see glutathione is the body's master antioxidant. We're going to talk about what that means and that it supports the immune system. And I'm going to focus on the antioxidant part of the glutathione's properties, but I will tell you a little bit about the immune system. It improves overall health, and it's a patented form of phototherapy, which we have general slides and presentations on phototherapy if that's new to you. But it has no drugs, chemicals, or stimulants. It's simply your light being reflected back into you in a very special way. So I looked at LifeWave's patent with respect to glutathione, and the patent actually protects their device, that is the patch, and it protects the way the patch increases glutathione levels in the body. So we're going to talk about what's known about glutathione first and what it does. So why do we care? And then what we can find that's known about what LifeWave patch does. So join me in this exploration. And here we go. So first, glutathione is well established in the biology literature, and it is well known that high levels of glutathione are associated with longevity. So people over 100 years old have significantly higher levels of glutathione than the general population. There are like 90,000 studies that have been published on glutathione, and it includes a lot of what it's used to treat. Supplements are used to treat Parkinson's disease, cardiovascular damage, cancer treatment, autoimmune diseases, autism, the list goes on and on and on. And so we could talk for this whole hour or half hour, however long this will go, on the diseases, but the point of this talk is to explore more about the underlying biology. But given the list of diseases for which glutathione supplements are given as a treatment, it's real clear that glutathione is really, really basic. And the patch is, we don't claim that the patch is going to cure any of these diseases, but the company does claim that the patch increases glutathione, and it's well established that glutathione has an effect on all of these lots of disorders. So here's just a list of some of the claims that one can easily find on the web for glutathione benefits. It's going to increase energy, slows down the aging process, reduces muscle and joint discomfort, strengthens the immune system, detoxifies the liver and cells, improves mental focus and clarity, improves quality of sleep, reduces the effects of stress, improves the skin, and helps with athletic performance and recovery. Well, you can see that's just a wide, wide list. I put this website where I found this particular list, but there are lots of lists similar to it on the web. What I found was interesting here is that you can't live without glutathione, that if you go 24 hours without food, your liver starts stealing the amino acids from the protein in your muscles to make the compounds that it needs to make glutathione. So I imagine that when we hear of things like muscle wasting, that this could be a big contributor, is that your body needs more glutathione. And I'll explain why that is the case as you age in a minute. But where do you find glutathione in your body? When your body has lots of it, then highest concentrations are in the lungs, the liver, and the brain. So we'll focus, the information I believe about the lungs is relatively new, and we'll focus primarily on the liver and a bit on the brain. So look at that molecule, actually a few molecules strung together. At the bottom, we have what one looks like, just a little sketch. It's produced in the liver and by neurons in the central nervous system. So it's produced naturally, you make it all the time, but its effectiveness decreases with age, and it's not really very successful to take supplements because this is such a big molecule that it's very, very hard for your body to absorb it naturally. And so you get very little bang for your buck when you take it as a supplement. And it's this great big molecule that the body just, as it's going through your digestive system, it gets broken up. And then it gets clustered together. You can see these big lumps, and it's just hard for you to make, to get into your body. So I'll just point out one thing here. The N's are nitrogen. The H's are hydrogen. The O's are oxygen. I want to point out this S here because the abbreviation for glutathione often in this particular form is GSH. And where does the S come from? Where that's sulfur, and it's that little piece that's hanging off here, and it's important for detoxification. So glutathione is actually constructed from 3 different peptides, and here it's kind of broken apart so you can see the separate ones. And these are 3 separate amino acids: glycine, cysteine, and glutamate. So we'll talk about them a little bit, but what is on this slide is where you find them. So cysteine is really abundant in protein-rich foods. So as long as you get plenty of protein, you're getting your cysteine. Glutamate is the most abundant amino acid available in the human diet. So you don't typically have to worry about that. Glycine may be more difficult to get depending on your diet. So it's a good source of bones, and not a lot of people go around chewing on bones anymore. Although when I was a kid, that was considered a very important thing to do. It's in connective tissues, gelatin, and legumes, such as soybeans, tofu. And so you can see that some diets, as in the Chinese and the Indians, etc., will get a lot of glycine, but the general American diet may be low on it unless you're paying attention. So as I said, today's focus is going to be on glutathione as an antioxidant. These 3 descriptions are really somewhat of the same, different ways of talking about an antioxidant: a free radical scavenger and a detoxifying agent. So we're going to talk more about what all those words mean. This little picture shows you what happens with oxidative stress, which I'll define for you, but you can see the little teeter-totter. And if you have more free radicals than you have antioxidants, then you're set up to have a lot of damage in your tissue, and the damage will result in your actual tissue being injured from the inside out, and inflammation, which of course can hurt your joints and lead to autoimmune diseases. So you would like to have more antioxidants than you have of free radicals. So if you look down here at the bottom, I've defined oxidative stress for you. I'm going to show you some pictures that'll make this a little more interesting, but you've got an atom, which is a free radical. Okay, so here's a free radical. Free radicals are atoms that contain an unpaired electron. So the atom is not stable unless it has its electrons paired. And so when it's missing an electron, it's going around your body or going around its neighborhood, wherever it is, looking for an electron it can steal in order to stabilize itself. So by ripping electrons off of other things, it causes damage to everything that it touches. And so oxidative stress is sort of the process of that happening without appropriate controls. You get the free radicals ripping electrons away from other atoms and molecules. And in the process of doing that, they create more free radicals that create more free radicals. And so without a lot of antioxidants, aka glutathione, you're really in trouble. So now let's look up here and see what kinds of things that glutathione actually helps with here. So it reacts with harmful chemical species, certain chemicals, to form harmless inactive products. That's really what it means to be a radical scavenger. And I've listed a few here. One are compounds called halides, and that includes chloride, bromide, and fluoride. It includes iodine, which your body needs, and glutathione mixes with iodine to do very productive things. But with these others, it will bind with them and then detox or give them a protein to stabilize, an electron to stabilize them. So when these halides blend with steel and different metals, they become salts. So a salt which we all need is sodium chloride, and that is a halide. As is fluoride and hydrochloric acid, which of course is pretty strong stuff. You don't want it in your body. It also then reacts with epoxides. And so when you think of what is an epoxide, think of epoxy glue. They're highly reactive, often volatile alkaline agents. And so what's an alkaline agent? Well, alkylation is the process of taking a piece of a molecule from one molecule and giving it to another. And again, that can be a normal part of your bodily function, or it can be an undesirable feature. And it's undesirable when what's getting ripped off is producing free radicals. So this is the big picture of where glutathione is operating. There's a lot of things we're not going to talk about today, and I will just read what's in yellow here and leave the rest on the slides in case someone wants to read more about it later, and we may have a talk on it more later. So glutathione actually makes chemicals and proteins that are needed for building tissue and repair. And it's critical for immune function and for controlling inflammation. As I say, I'm not going to read all these bullet points now. We may come back to it another day, but I will, before I go on, talk just give this slide that says a little bit more about, I don't think it gives a little bit more from the immune system, what glutathione's doing. So your body actually can't make white blood cells without enough, if it doesn't have enough glutathione. So white blood cells are the primary foot soldiers for your immune system, and they protect us from all kinds of viruses and bacteria, et cetera. So that's big stuff. Higher levels of glutathione are also known to preserve telomeres, which we talked about at our last presentation. And they're the tail ends of the genes that need to be there, and they disappear with age. So this is an important contribution that glutathione makes to anti-aging. And then the third thing here is that it has natural killer cell activity. So this is particularly important for destroying cancer cells. So all of that we could talk much more about, but we will talk about glutathione as the master antioxidant. So first look at the picture here. We've talked about the free radical having its pairs of electrons going around, but then right here, we got one electron that doesn't have a mate. And then we have an antioxidant that might be, that could well be glutathione, but it could be vitamin C or some other antioxidant. And it's got a electron it's going to give to the free radical. And then when the free radical's paired up, it's not going to go ripping off other cells, and it will behave itself. So all the antioxidants have this in common, that they're going to give an electron to make a free radical stable. But what makes glutathione the master antioxidant? Well, one is it's pervasive around the body, but the real kicker is that it regenerates itself in the liver. That is, it gives up its electron. And if you take like vitamin C, you have to take vitamin C every day. When vitamin C gives up its electron, it's done for, and your body will, break it up and use the parts for other things or flush it from your body. But with glutathione, it goes into the liver, and the liver fixes it up with an electron again, so it can go back and do this antioxidant behavior repeatedly over and over and over again. It also boosts the activity of other antioxidants in the body, like vitamin C and vitamin E. So a little bit more about free radicals. They come from both inside and outside the body. So on the left, we have a picture of free radicals coming in from outside the cell. So in the inside of this picture, the center of the picture is a little double helix of DNA, and it's going to get damaged from, here's UV light and inflammation and air pollution and cigarettes and lots of toxic things that you might take in from the environment or ingest yourself. So that's one way that free radicals get operating in the body. But they're also produced naturally inside the body. They're just a common byproduct of normal cellular metabolic oxidation processes. So, for example, they're produced in the normal process of making ATP, which is your body's basic energy package. And when you then have the free radicals, you need something to bind them up and take care of them. So we talked about the free radicals creating more free radicals, but even glutathione when the liver has like two phases. And in the first phase of detoxification, the glutathione binds up the toxins, and then that will help, you know, prepares the toxins for elimination. But in the process of doing that, it creates more free radicals. And in the second phase of the liver's process, it needs even more glutathione to get rid of the antioxidants it created in the first phase. So lots of activity and glutathione in the middle of it all. Now I'll just highlight a few things here. It's a busy slide, don't try to read it, but there are different types of antioxidants, and part of, and glutathione comes in a variety of different forms for these different types. So here we first, antioxidant can be an enzyme. What's an enzyme do? An enzyme is something that works in a chemical reaction to make it go. You kind of have to have the enzyme to kick start it. So glutathione in this form, glutathione peroxidase, works as an enzyme. And to do its work, it needs things like, it needs copper, zinc, manganese, and iron. So non-enzymatic antioxidants, so we talked about, so non-enzymatic antioxidants work by interrupting the chain reaction of the free radicals, that reaction we talked about. And examples of those antioxidants are vitamin C, vitamin E, carotenoids, and glutathione in its basic form. So another way to sort of classify the antioxidants is water soluble or lipid soluble. So the water soluble antioxidants are in cellular fluids, and lipid solid antioxidants are located in cell membranes. And lipid is, of course, fat. And then the antioxidants can be big or small, and glutathione comes in relatively big and small forms. Glutathione's never really small, but in this form GSH, it neutralizes the action of your free radicals and carries them away. And in the large molecule form, it prevents the antioxidants from attacking other proteins. So very real complex, lots of different ways in which these antioxidants operate. And just a few more comments. Well, I guess this is just notation that glutathione, you see many different symbols. If you're looking at abbreviations, you find glutathione has a whole lot of different representations as it changes. So this next point's really important with respect to health. So in a young person, 90% of the glutathione in the body is GSH. Okay, so this is glutathione that is been used, that is ready to be used, ready to give its electron to something that's needed. And only 10% of the glutathione is in this other form, which is the oxidized form, which is spent. You know, it's done its job and it can't do anything more until the liver fixes it up and gets it back into production. What happens when you age is that these ratios flip. And so the liver is no longer cleaning up the glutathione and getting it back out there to do its job. So it's, that's why we need something to keep the glutathione healthy and in balance and enough of it in the right form. So now I'm just going to talk a little bit about what we know about glutathione, the glutathione patch. As I say, because you're not taking a supplement, you're not trying to take that big molecule into your body and make use of it, but you are going to, the light that's reflected from the patch is going to signal your body to make it glutathione yourself. And that's actually one of the findings from the studies. So we have 1, 2, 3, 4, 5 studies. The complete papers can be found on the LifeWave, on LifeWave, my LifeWave website or the main LifeWave website. They're all small sample sizes, unfortunately. And the timing here spans from 2011 to 2006. And we'll see talk about them in reverse order here. So Dr. Connor and her colleague used a piece of equipment called a gas discharge visualization equipment. And you see a little picture of what it looks like up here. It's really the new version, the new improved way of, it's the descendant of Kirlian photography. So here's a leaf, and when the leaf's nice and healthy, everything's bright and shiny. And when the leaf's sick, everything looks dull and bad. So this was a double-blinded, placebo-controlled, randomized study, which is all very good, but they only had 10 patients patched and 10 controls. Their observations are that the patterns of, this is gas being emitted from the edges of the leaf in the example, and in people, they look at the gas being emitted from the human being. So they looked only over the period of 1 hour to see how much would change. And they did see changes in gas emission in that short period of time, and primarily in the solar plexus region. Note here, they put the patch, well, it's interesting. They put the patch down here below the belly button, but most of the changes were up in the solar plexus area. Not too far away from each other, the liver, the kidney, and the nervous system. And in contrast, the control subjects did not show change over time. Miller and his colleagues evaluated acne and whether the glutathione patch could be used as an whether it would have an effect on acne. They also did this together with a homeopathic spray, which LifeWave no longer produces. So I don't know, it's curious what happened to that. But the subjects got both the patch and the spray. And to be admitted to the study, they all had mild to moderate acne. They used the patch now for 6 weeks. So it's a good, reasonably long time with the spray. And they observed them regularly, took measurements regularly, and observed improvement after 3 weeks of patching, which they patched for several more weeks and saw the improvement stay. Sherry Blake Greenberg and Homer Nazarin studied the patches using electrointerstitial scan. And we've talked several times now about that piece of equipment and the questions and issues surrounding it. But it operates much like an EKG. And what they looked at, so you've got the leads on the body measuring the flow of energy around. They had 2 groups of patients. Controls were 10 subjects, and well, not controls, excuse me. Cohort 1 is 10 subjects, and cohort 2 is 20 subjects. And the difference is timing. So this is the only study I've seen so far where they actually looked at timing, and it kind of comes out backwards from what I expected. So the one group had their patches on daily for 4 weeks. And the other group had their patches on for the same overall duration of 4 weeks, but only 5 days a week. So there was a list of organs for which they studied the energy flow through and around the organs. And in cohort 1, which got the daily patching, the only organ that did not significantly improve was the pancreas. Whereas in cohort 2, that got the patching 5 days a week, the adrenal glands, the hypothalamus, and the pituitary improved, but they did not see improvement in liver, gallbladder, intestines, or the pancreas. So the reason this is kind of surprising is because the CEO, David Smith, talks often about making sure that you pulse the patches and don't let the body get really used to the signaling from them. Like you don't want to get used to, like you do want to get used to not hearing a train at night, but here we want the body to react all the time. So the only pulsing that's going on is the 12 hours per day, 12 on and 12 off, and that's the same in both groups. So I'm not sure now. A lot of people say they do use the glutathione daily. And I'm just, question for David would be, are there really different, do they know enough to know that there'd be different pulsing, optimal pulsing strategies for different patches? Or does he really figure the 12 hours on, 12 hours off is sufficient, and that one can use the patches 7 days a week? So that's a question. Tully, 2010, and colleagues did a study with only 9 subjects. So the one of the big problems with with a small sample size is you have a high chance of missing something that's really important, because because you don't see it, you don't have enough what they call power to be able to see it. So here again, the patches are applied for 12 hours a day, and they rotate between the acupuncture point CV6 and CV17. Now, they did a number of tests. They looked at the whole blood enzymatic levels of glutathione. They looked at how the enzymes themselves operated. And then to get an idea about toxicity, they looked at urine levels of mercury. And they found that all subjects increased their blood glutathione. So here's a little chart of that over time. They start out, here between 100 and 150. And by the end of the study, they're up well over 300. So that's consistent with standard error bars here, showing that it's consistent for the groups. The other things they measured did not show, well, this is a very nice study. They included pictures for each subject, as well as for averages, which you're looking at here. And the blood glutathione was pretty, consistently increased for the subjects. Other things had some mixture, but they really didn't have enough subjects to see whether, what a population effect might be. And so I think the jury's out on whether if they did a bigger study, they might find changes in urine, mercury, etc., evidences of the toxic detoxification. So the last study is by Mr. Hallewager, Wanger, and he patched 10 subjects and used 5 control subjects, very small number of control subjects, but then he just compared everybody to their controls. And to be eligible for this study, they had to be 6 months worth of pain. He did this study with LifeWave too, but I'm focusing on the results that were presented for glutathione. They looked at the test results after 24 hours of measurements. So this is very short-term duration, and they had these 5 different pieces of equipment that they used to take measurements with, so a lot more measurements than that. What they found out that was interesting is that the measurements were correlated across all devices. So people tended to be consistent, measured on one device, you got a consistent sort of impression or inference about what was going on with that person from the other devices. So you didn't really need to do all 5. The changes again that they saw were in the solar plexus. They also saw changes in the lower back and in the biofield specifically outside the body. And they noted that blocked chakras, particularly the solar plexus chakra, were seen to open up with red congested energy being replaced by green or violet healing energy. I hoped they'd have a picture of that, but I didn't see one. So maybe there's a picture somewhere I missed. Okay, so that's it for glutathione, and I wish to thank you for listening, and my website is here at the bottom, and I'll turn it back to John.
Thank you, Nancy. That was great. That was really good. Boy, I learned a lot today as usual. Boy, about that, unblocking that solar plexus chakra. That's what I'm going to focus on right now. So yeah, thank you for joining us today. Again, this glutathione patch can be either through Nancy or the person who introduced you to this. You will get it directly from the company. They have a 90-day, 100% money-back guarantee if you're not totally satisfied, which is one of the amazing things about this company. They really believe in their products. So, and I got to tell you, I've been using glutathione for a little over a year, and I've noticed a big change. Sometimes I switch it around. There's different points. Usually I put the one that's about 3 finger widths below my belly button, and my wife does that as well, and it's been really good for both of us. We felt like our
got one right there right now.
yeah. So hope you can try it, and I hope this has been informative. And again, just get back with the person that introduced you to this, or Nancy or myself. So thank you, Nancy, very much, and we'll
Thank you, John. Have a good evening.
you too. Thank you.
Bye-bye.